Welcome to the GeoMethod channel. Today we are solving another interesting geometry problem. Here is today's challenge. Can you find area and perimeter of the triangle? Take a moment to study the figure. Then let us uncover the key geometric ideas that make the solution click. Look at triangle ABC. Side AB equals 2. The angle at A is 105 degrees, and the angle at B is 45 degrees. Those three facts are everything we are given. We want two things about this green triangle, ABC, its area and its perimeter. Only one side length is given, so we need to turn the two known angles into the missing side lengths. The three interior angles of any triangle add to 180 degrees. Taking away the 105 at A and the 45 at B leaves exactly 30 degrees at vertex C. Now we know all three angles. Both remaining angles, 45 at B and 30 at C, are angles we can compute with exactly. If we can build right triangles that carry them, we can read off every side. The clean way to do that is to drop an altitude from A. Draw a perpendicular from vertex A straight to the left to side BC and call the point where it lands D. This new segment AD is the height of the triangle, and it meets segment BC at a right angle. Because the angles at B and at C are both acute, the foot D lands strictly between B and C. So the altitude cuts triangle ABC into two right triangles that sit side by side, and side BC is split into two clean pieces. Our first insight is this. The altitude creates a 4-5-4-5-9-0 triangle. In the blue triangle, the hypotenuse segment AB equals 2. The height segment AD is opposite the 45-degree angle at B, so it equals 2 times the sine of 45. That is 2 times root 2 over 2, which simplifies to root 2. Since the blue triangle is isosceles, its two legs are equal, so the base piece segment BD also equals root 2. That takes care of the top half of side BC. A second insight now finishes the structure. The other half is 306090. Notice how the height segment AD sits directly across from the 30-degree angle at C. That single fact lets us pull out the other two sides of the gold triangle using the sine and tangent of 30. The hypotenuse segment AC equals the opposite leg segment AD divided by the sine of 30. That is root 2 divided by 1/2, and dividing by 1/2 doubles it, giving 2 root 2. That is our second side length. The left-hand leg segment DC equals the opposite leg segment AD divided by the tangent of 30. The tangent of 30 is 1 over root 3. So dividing multiplies by root 3, giving root 2 times root 3, which is root 6. The foot D split side BC into the two pieces we measured. Adding them back together, segment BC equals root 2 plus root 6. Now all three sides of the triangle are known. The perimeter is just the three sides added up. Segment AB plus segment B, C plus segment CA. Let us substitute the values we found for each one. Side AB is 2, side BC is root 2 plus root 6, and side CA is 2 root 2. Dropping those in gives 2 plus root 2 plus root 6 plus 2 root 2. The two root 2 terms combine. 1 root 2 plus 2 root 2 is 3 root 2. The root 6 and the plane 2 have nothing to combine with, so the perimeter is 2 plus 3 root 2 plus root 6. For the area, the altitude already cut the triangle into the blue piece and the gold piece. So the area of triangle ABC is simply the sum of those two right triangle areas. Let us find each one. The blue triangle ABD has base segment BD and height segment AD, both root 2. Half of root 2 times root 2 is half of 2, which is exactly 1. The gold triangle ACD has base segment DC equal to root 6 and the same height root 2. Half of root 6 times root 2 is half of root 12, and root 12 is 2 root 3. So this area is root 3. Gluing the blue piece and the gold piece back together, the whole green triangle ABC has area 1 plus root 3. The area is done. So the answer is 1 plus square root of 3 and 2 plus 3 square root of 2 plus square root of 6. That completes the solution. A good geometry problem often has more than one beautiful solution. If you see a genuinely different construction, a high-level idea that leads to another solution, or a thoughtful adaptation of an existing method, share it in the comments. Even a rough idea is welcome. A sketch of the key move is enough. We greatly appreciate these contributions. With your permission, we may feature the approach in a future Viewer Solutions episode and acknowledge you by name or channel handle. Thanks for exploring geometry with GeoMethod.